All right, so in your syllabus, this lab is going to be titled something like Density of Salt Solutions, Day 1 and Day 2. But it's really titled Density, I believe, in your lab manual. And the density lab is broken down into 3 separate sections, Part A, Part B, and Part C. The salt solutions is just one of these parts. That's it. The other 2 parts deal with a density of a solid and a density of a liquid using what we call a pycnometer. So we're going to talk about all 3 parts, but what you need to realize is that this is your first multi-day lab. So this is going to be divided up into Part 1 and Part 2 because it will take 2 lab periods for you to complete this lab in its entirety. There's a lot of things that are going on. It's simplistic in nature as far as what they want you to do. But just because there's so much of it, we're going to have to divide it up into 2 3-hour blocks. So Part 1 and Part 2. Okay, first thing that you need to realize is that when we begin this lab, you will be divided up into 2 groups. We will call you Group 1 and Group 2. Nobody said that we had to be fancy. We can do whatever we want to, right? So Group 1 and Group 2. What will happen is that depending on who I like the best, or who sucks up to me the best, or who brings me an apple for the day, Group 1 and Group 2 will be divided up based on what they will be doing for that particular lab period. Group 1 will either, let's say, do the density meter. The other group will be doing the density by hand. And then what will happen is that on the next date, we will switch those groups around. And Group 2 will then do the density meter, and Group 1 will then do the density by hand. So that is one of the reasons that we break this lab up into 2 parts, because we have 1 density meter and then we have 14 students fighting over it, and then we can't really do anything at all because the density meter takes time. And sometimes for me to explain the density meter, to walk you through the steps to properly inject the sample and how to print off a report, that takes some time. And then we add on top of that the amount of time that it will take you to run the samples on the equipment. Well, by the end of the day, you're probably already have exposed 3 hours of lab time just to go through that process. Okay, so let's talk about the hand measurements first, and then we will talk about the density meter at the end. Okay, so let's say that I am in the group, and I'm just going to put question mark, that will be doing the density by hand. Well, there's 3 things that they want me to do. Number 1, they want me to take a solid. And we're going to give you an unknown solid, and you will have to measure the density of this solid by hand. Okay, so how do we do that? Well, it's a pretty simple process. What we do is that we take a graduated cylinder with the tick marks on it, and we fill it full of a certain amount of water, and then we take this solid chunk, whatever I'm given, and I dunk it down into the graduated cylinder, and this solid chunk takes up space. And because it takes up space, this is a volume measurement. Well, when I put it into the water, what will happen is that it will displace the water to a new level. And this difference, what the water level was before to what the water level is now, that is what we call the water displacement. And that is equivalent to the volume of my solid object. So if I've given an irregular object that I cannot measure the length, width, and height by a ruler to get a volume measurement that way, One of the ways that I can get this volume is dunking it down into a graduated cylinder or another suitable container and measuring the volume displacement that happens with that solid. And that gives me the volume, the amount of space that irregular solid takes up. A very easy way for me to accomplish that in the lab, and that's all that I need. Graduated cylinder and some water. I'm then going to take this solid chunk, and I'm also going to weigh it, get its mass. I probably would want to do this first, and the reason is because I would want to do it first. I wouldn't want any water on it, wouldn't want any crud on it. As soon as I get the object that's given to me or that I pick from, I'm then going to take that object, I'm going to put it on the scale, and I'm going to get its mass. 4 decimals after, remember? And then I can do the water displacement. And then I've got the ingredients needed to do my density calculation. I have mass, and then I have volume, and I take the two and I divide them, and I get density. Okay, so that's going to be part A. Once I get my density measurement, I will then turn around and take a look at the table in the lab book. And this table will give me options. And I can pick from any of these options. So I'm going to have to identify what this unknown solid really is. And I do that by comparing a density measurement to it. So for instance, if I get a density measurement of 9, I'll go to the chart and I'll figure out what in that chart has a density close to 9. And I'll realize that this is probably copper because that's the one that it comes closest to my actual measurement. So that's part A. Part A is determining the density of a solid, or part 1 is. Okay, if I'm this same group where I do everything by hand, I then go to the second part of the lab. And the second part of the lab is going to concern the liquid. And this is actually embedded in a way, if you're not careful, it's embedded at the bottom of that table. So a lot of people will skip over part 2 just because they overlook it. Please do not skip over part 2. It is a part of the lab that we do. So part 2 is at the bottom of that table, and it's called the density of a liquid by a pycnometer. Okay, so this is a liquid. And I'm going to measure this liquid by something that we call a pycnometer. P-Y-C-N-O-M-E-T-E-R. Pycnometer. It's like picking a nose. Alright, so with this pycnometer, what will happen is that I will have this little glass vessel. So we'll have the pycnometers set up for you, and they kind of look something like this. They have a rounded bottom on them, and they have this funny little cap up at the top. And what will happen is that I will fill this pycnometer. Well, before I do that, though, I'm going to take the mass of the pycnometer. And then once I get the mass of it completely dry, completely clean, I'm then going to fill this pycnometer up with water all the way up to the top, all the way, overfill it so it comes out of the side. And then once I overfill the pycnometer, I'm then going to take the special little cap that goes on the pycnometer, and I'm going to place it on top of the pycnometer. And what will happen is that it will squeeze out all of the water that doesn't need to be in there. I have a completely full pycnometer of water. So overfill it until it runs over the side. Put your cap on it, and that will push any residual water that doesn't need to be there out. And you want to make sure that you do not see air bubbles. No air bubbles. Air bubbles are bad. And the reason is because air bubbles take up space, and if I take up space, then I think that that space is supposed to be made up of water, but it's not. It's made up of air, and my density will change because of it. So with the mass of the pycnometer, I now have a full pycnometer, and then I can take the mass again. And I can take these two values and I can subtract them to get the mass of the water that's in my pycnometer, right? That's how we do that calculation. So to do the calculation for the mass, I take the mass of the pycnometer, so PyCno, plus the water, minus the mass of the empty pycnometer, and that will give me the mass of the water only. Okay, so this is a good number for me, right? So this is my M value. Okay, well, I'm doing density here. Other than M, I need V, and V stands for volume. Well, on these pycnometers, you will see that they are specially calibrated to hold a certain amount of volume every time. So the volume of the pycnometer will be given, and that will be labeled on the pycnometer itself. So now I've got mass, now I have volume, and the only thing that I need to do with these two numbers now is plug them into the density equation and take the two, divide them, and get a density number. Okay, well, this is water. So hopefully, if I do this the right way, I will get, in the first half, with my water measurement, something close to 1 gram per mil. If I don't get something close to 1 gram per mil, I'm doing something wrong. So this is kind of like a self-check for us with the pycnometer method. Take the pycnometer, get its mass, fill it full of water, put the cap on it, get its mass. Take the mass of the water that it takes to fill that pycnometer up, divide it by the volume of that pycnometer, what it will hold, that gives me density. Hopefully that density is close to 1. If not, I've done a measurement wrong, my technique is wrong, something that I'm doing is off, and I need to figure out what that is. Okay, well, that's the first part. The way that this lab is worded, it's almost like they want you to do this last, but do not do it last. You do this first. Then with part B is that we will have an unknown liquid, and you will do this with an unknown liquid. Same process, there's no difference. You take the pycnometer, empty the water out, make sure it's completely dry. You do not want any extra water weight. You will then take, or contamination, you will then take your unknown liquid, you will fill it full, just like you did with the water, put the cap on it, just like you did with the water, and weigh the pycnometer with the unknown liquid in it all over again. And then you will do the same calculation, and you will give us and provide us the density of an unknown liquid. We know what that density is. And again, we want you to be within plus or minus 10%. That's kind of the key here. So I'm going to box that in red because we want you to pay special attention to that number and that measurement. That's what's going to set you apart from everybody else when you apply for those jobs. And then finally, for you people that are doing it by hand, number 3. We are going to give you an assortment of salt solutions. And these salt solutions are going to be 4, 6, 8, and 12, I believe. Maybe I'm wrong. 4, 8, 12, and 16. Sorry. No 6 allowed. 4, 8, 12, and 16. You will get the densities of each one of these, and you will do this by hand. Well, how do you do it by hand? Well, you pipette. Well, we've already went through the process of pipetting. You know that by now. You take out the pipette, you take out the pipette bulb, you pipette out a certain amount, deliver it into a vessel, and weigh it. So because of the pipetting technique that you've learned maybe a week ago, you will use a pipette to get the mass of each one of these solutions, and you will know how much you've pipetted because it will be stamped on the pipette itself. How much? Well, pour in between or use in between 1 mil to 10 mil. It doesn't really matter. We don't care. You pick whatever pipette you want to use. The lab procedure is going to tell you to use a specific amount. I wouldn't be surprised if the lab procedure tells you to use a graduated cylinder.